Hi children, this is your physical science facilitator SS from Commando Group of Schools. Welcome to the online classes. In the last session, we learned applications of TAR and refraction and day-to-day life examples for the refraction as well as TAR and some important concepts also. In this class, I have to go for an important 4-mark question about glass lab activity. Okay, so the question will be asked in different manners. That show that angle of incidence is equal to angle of emergence, like that they've asked, or write an activity to find vertical shift or lateral shift, like that also they are going to be asked. Mostly first lateral shift, then vertical shift. Okay, like that also the question will come. Or write an activity when light passes on a glass slab, like that also. Based on the question, our aim is going to change us. For example, the question is given like this: show that angle of incidence is equal to angle of emergence. For that, what is our aim? To prove that angle of incidence is equal to angle of emergence. That is our aim. For this, what are the requirements? First, we have to take one white chart or a cardboard like this. Okay, let us consider maybe cardboard. On this cardboard, a white paper has fixed with the help of pins. Okay, so with the help of pins, it has been fixed. So, like this. Or otherwise, we will take a big chart because you can easily understand how it's going to happen. First, I'm going to take a big chart. A big chart like this. Okay. Now let's fix it with the help of pressing pins. On this chart, white paper has fixed, white chart has fixed. Now, in the middle, take a glass slab. Okay, take a glass slab like this. A rectangular glass slab. Rectangular glass slab has fixed like this. And with the help of a pencil, we have to trace it outer edges. Okay. And after tracing, remove this glass slab and insert a light ray like this. And it touches here this, what we call this point of incidence. From this point of incidence, we will construct a normal. Okay, then you can measure this angle with the help of protractor. It will use that angle of incidence. Angle of incidence. Now let us see what are the requirements. Now we can understood. Chart we need, pressing pins we need, rectangular glass slab we need, pencil, pins, protractor. Okay, of course, scale. These are our requirements. Now, let us see the procedure. First, take a white chart, keep on the cardboard and press with the help of pressing pins. Take the rectangular glass slab and keep at the middle. Now, with the help of the pencil, trace the outer surface. I have written it as A, B, C, D. Now A, B, C, D is a rectangular prism. Now remove the prism from that and with the help of a scale and a pencil, draw an incident ray towards CD. Now CD is the surface towards the CD. Now it touches the CD at one point, the vertical point of incidence. From that point of incidents, what you have to construct? A norm. Okay. Now, keep the glass slab here. Again, keep the glass slab exactly coinciding with this. Exactly coinciding with this. And keep two pins, press two pins on the surface of this incident ray as P and Q. P and Q. These are the two pins. Now what is there in this ABCD? Glass slab is there. Now we have to observe these images with the help of this side. From this side onwards you have to observe the images. From other side of the glass slab. From this side we have to observe the images of P and Q. P and Q. For example, if the glass slab is not there, then what happened? It has to move like this, straight, you know. Okay, it has to move straight. But glass slab is there. So if you observe the images, then what happened? Okay, so let us see what happened to them. Now if you see here about normal, it is about rarer medium of air, and glass slab is a denser medium. Now the light is going from rarer to denser. When it is going from rarer to denser, what happened to move? Towards the normal. So this is about the refracted ray. So what we call this angle of refraction. Here it is touching here now. So from here we will construct one normal. This is also angle of refraction. These two will be equal now. Okay, we say with respect to yes. These two are parallel because rectangle now. Opposite sides are parallel. Now this is a transversal line. So that these two angles are very equal. Okay. We are not going about the maths. Now if you see, let us say this is an incident ray. You are observing these images now. If you observe the images from this side, you can observe they may be here like this. Here one and here maybe one more. Like this two images. Images of P and Q. Now we observe if we join these two, it can be like this. It is about P dash, of course. Outer side now. It is about P dash and it is about Q dash. This angle is called as angle of emergence. Angle of emergence. See once again what we did here. First, take a white chart on the surface of a cardboard, and with the help of pressing pins, you have to fix it with the help of pressing pins. On the middle, arrange the glass slab and trace with a pencil and let it as A, B, C, D. After tracing, remove the glass slab. With the help of a scale and pencil, draw an incident ray towards C and D. At this point of incidence, construct a normal. And with the help of protractor, measure the angle of incidence. Now, on the surface of this incident ray, press two pins called P and Q. Two pins. Again, carefully insert the glass slab exactly coinciding with the ABCD. Okay? Now, observe these images of P and Q from this side of the glass slab. When you observe from this side, the P dash is the image of P, Q dash is the image of Q. Two images can be. Point the two images and extend the line. It will touch this line A, B at one point. That is also one point. From that point, construct one normal. Of course, when it go like this normal. Now when you join these two, it will become considered as a refracted ray because it is moving from rarer to denser. It is exactly moving towards the normal. Because it is going from rarer to denser. Okay? Now, remove the glass slab and extend with this one now. If you observe this angle here is the one angle. This angle and this angle are equal. What we call this angle? Angle of incidence. What we call this angle? Angle of emergence. Okay, you may consider those points also. For example, it is maybe N and it may be M. Now here the angle at M with respect to normal is equal to this one. So what we call this one? Angle of incidence. Angle of incidence. What about this one? Angle of emergence. Angle of emergence. What is our aim? To prove that angle of incidence is equal to angle of emergence. Both are same. Sometimes the question may be extended. What is that? Write an activity to find the vertical shift. Vertical shift. Let us see the vertical shift also. If the question is given like this, prove that the angle of Y is equal to angle of E. Then what is the observation? What is the observation? I observe that angle of this one. Incidence and emergence is equal. What is your conclusion from the above activity? I conclude that whenever light passes through a glass slab, that angle of incidence is equal to angle of emergence. That is your observation. If you want to write the precaution also, you can write exactly should be coincide after removing and inserting. Okay. Right. Clear? Then what is by that lateral shift? Let us say lateral shift. Lateral means side. Lateral means side. Yes or no? Laterally inverted means right will become as right, left will become as right. Lateral. Here also lateral shift. Lateral shift is nothing but when you extended this one. When you extend this. Okay, I am going to extend. This is the incident ray now. I am going to extend this incident ray like this. Let us consider like this. And I am going to extend this one also. This one, emergent ray. I am also extending this emergent ray also. What do you notice? These two? Okay, these two are parallel to each other. These two are parallel to each other. Means the distance between this incident ray and emergent ray. Incident ray. For example, I am going to consider as here N now. So it is maybe S and it may be Q. Now MQ is parallel to SN parallel, and the gap between these two, or the distance between these two is going to be considered as lateral shift. Lateral shift. Have you understood what is lateral shift? When you extend this incident ray and emergent ray, they are parallel to each other. Okay, the question may be asked like this also. What do you observe when they are being extended? They are parallel to each other. So that the gap between means laterally is shifted now. From here, now it is shifted like this. Okay, so laterally shifted, side. From side it has been moved like this. So how much it has been moved? How much it has been moved? Like this. Have to be understood. But here, this lateral shift is depending on some physical factors. Have understood, children? This is very crucial question for 4 marks. Lateral shift is nothing but the distance between the incident ray and emergent ray. What are the factors that influence this lateral shift? Especially 3 factors are there. 3 factors. Factors that influence the lateral shift. Lateral shift is depending on few factors. Okay, listen carefully, because in competitive examination, such questions are going to be asked. Here, this lateral shift is first of all depending on angle of incidence. Angle of incidence. If the angle of incidence is increases, then vertical shift also increases, directly proportional. When angle of incidence is increases, suddenly what happened? Vertical shift also increases. If you increase this angle, the gap between this also going to be increases. Okay, it is the principle used in constructing of aeronautical substances. Okay, so very easy thing. Where how the light is passing like that. So factors influencing that is important for us. So if the angle of incidence is increases, vertical shift also increases. So it is depending or not. Yes. Next one, refractive index of the glass slab. Yeah, refractive index. Refractive index of the glass slab. Whatever the material you are going to take. So here the vertical shift, lateral shift. The lateral shift is depending. The lateral shift is depending on refractive index. If the refractive index is more of the given glass slab, then lateral shift also increases. If the refractive index is more, the lateral shift also increases. Right? Then, so two factors. So don't forget about the angle of incidence. If the angle of incidence increases, then what happened? Lateral shift also increases. If the refractive index is more for the given substance, lateral shift also more. And one more thing about thickness of the glass slab. Thickness of the glass slab. If the thickness of the glass slab is more, then lateral shift also more. These are the three factors which are influence the lateral shift. Clear one? Okay, of course, in the coming chapters also you can observe that violet color deviation is more, violet color, because of less wavelength. Okay, so here wavelength also influence this one. Of course, indirectly it is depending on the velocity, so that I am not right. So these are the three factors which are influencing lateral shift. Angle of incidence, refractive index of the glass substance, glass medium, and thickness of the glass slab. If the thickness of the glass slab increases, lateral shift also increases. Refractive index increases, lateral shift increases. Angle of incidence increases, lateral shift increases. These are the factors which influence the glass slab. Have you understood, children? Right. Now, let us see vertical shift. With the help of this glass slab and their applications also there. Have you understood how to write this one? So the question may be asked vertical shift, lateral shift, or maybe angle of incidence is equal to angle of emergence. Okay, so like that the questions are going to be asked and the factors influence. What happened with the thickness of the glass slab is increases, immediately the lateral shift is also increases. Now, vertical shift. Vertical shift, sometimes called as apparent depth to actual depth also. Okay, it's also applicative question. Most probably who are going to write the MTS examination, we should focus on this vertical shift. Okay, competitive examination, vertical shift to based on the refractive index, how it's going to be changes. Those applicative questions and logical questions are very important. Let us see. Okay, glass slab as usual, previous one. The procedure is same, evaporators, material required, everything is okay. Now, here, take a glass slab like this. Do you know when you arrange this glass slab, you can observe one thing very easily, of course. It's a glass slab like this. So this bottom of the glass slab, when it's kept on the paper seems to be raised up. Commonly you are going to observe, for example, your friend is in swimming pool. When you observe your friend in the swimming pool, its height has reduces and is going to appear bulges. So it's going to happen naturally. Okay, something is fallen in the water. Its size is going to increase. Previously also in the last class we observed the size of the lemon which is immersed in the water. Because of refraction it's going to happen. Right. Similarly the bottom line is going to appear raised. Now take for example one like this rod you will take the base. This one line incident ray. On this incident ray, just keep one pin. Just keep one pin. That is as P. Now, from this side, you have to observe. From this side. Okay. By observing this side, we have to keep one more pin exactly on the line where it's not going to be, it has to be covered. Okay, so at a particular position, you will keep one and the pin Q. That we are observing from this side, we are observing from this side, so that what happened, its position to be appear coming towards like this. One more example I will give. For example, take one. Have ever went to the Mahanadi? In the Mahanadi, the water is very pleasant, very transparent. If you keep the 10 rupees or 5 rupees coin, when it's entering into the water up to the bottom of the water, it can be seen very easily. Similarly, if you take a 5 rupees coin and throw in a bucket, when you see vertically, you can observe that they are very close to you. Means if I think go up to here, when I give my hand up to here, it can be catch. But when you insert it like this, up to here, your hand will be. Means object is going to appear as raised. Similarly, you are going to observe it from this side. Object may be there, P. But when you are observing from denser to other object, you can observe that the object is rising up, it's moving towards you. So that the position is going to appear as Q. Actual position is P. It is the actual position. What is the apparent position? Q. The distance between these two, actual and apparent, is called as vertical shift. Vertical shift. Clear? Okay, now this based on this vertical shift, plenty of applicative questions are there. I think you have understood about this. The gap between or the distance between actual position and it is about actual position, it is about apparent position. So the distance of the gap, between actual position and apparent position is going to be considered as vertical shift. Vertical shift. Okay. Now, based on this vertical shift, so many questions are there. How we can find the refractive index with the help of this one? Okay, refractive index of this one. Of course, in your textbook, the formula is given for the refractive index. Refractive index is about thickness of glass slab. Thickness of glass slab by thickness of glass slab minus vertical shift. Vertical shift. It is the given formula. Here, see one thing. Okay, I will give better example for you. Listen carefully. Listen carefully. Very easy concept only, but few children are going to be suffer like this. Maybe a difficult concept like that. But actually, very easy concept. It's about a glass slab now. Now, it is the actual position, and it is about actual position, and it is about apparent position. The gap between these two is about vertical shift. Now I am changing that like this. Object is here. Object is here. Okay. I am going to measure here. It is the object. Okay. Means enter the glass slab. Means at the bottom of the glass slab. Okay. Are you able to understand? This is a glass slab now at the bottom. So at this line. Means at the bottom the object is there. Means what is the actual depth? Are you able to understand why? It's a glass. It is a glass. In this glass, I get the coin in that one. Okay. So what is that actual depth now? About this length. Okay. I will take this one as an example. I am going to take. Okay. 1 second. So let us consider this one as a glass slab. This one. In this, I am going to take object. Let us consider, and actually this one, let us consider. I am going to take this into this one. Okay. Now, what is the depth of this object? It is about the depth of the glass slab. Let us assume it is a glass slab. Now, actual depth is about depth of the glass slab. Nothing but thickness of the glass slab. From here to here. Let us consider it is entirely closed. Assume like that. Now the object is at the bottom. Now thickness of this glass slab. So actual depth is equal to thickness of glass. Sorry, thickness of glass slab, actual depth. But when you add water, what happened to that position? Its position is going to be changes. It's going to be raised. When I am going to observe, its position has raised. Okay. So when you observe a position, is not going to appear here. It is actual position. Actual position means from here to here. It is about actual position, means actual depth. Actual depth. But what is happening? This object is not appear here. It seems to be appear here. Means it's about apparent depth. Means from here to here. It is apparent depth. Clear? Okay, children, have understood this? From here to here. From here to here means thickness of the glass slab. Thickness of the glass slab is about actual depth. Actual position or actual depth I am going to write. Actual depth. Now here it is appearing now. So it is about apparent depth. Now tell me what is the gap between these two? What we call these two? It is actual position. It is apparent position. The gap between these two is called, very good, vertical shift. This is called as vertical shift. Now see the formula which is given to you. Refractive index is thickness of glass slab. Thickness of glass slab is nothing but actual depth. Actual depth by thickness of glass slab total minus vertical shift. What is there now? For this entire I am removing this one. For out of this I am removing this one. What do we get here? Apparent depth. Very good. Apparent depth. Finished. So refractive index formula is about actual depth by apparent depth. You can use that formula directly. Okay, it is also the same. Of course, it is there in our textbook. You can use this one also, no problem. I understood how we have to identify the refractive index. Thickness of the glass slab by thickness of the glass slab minus vertical shift. Okay, clear? I am going to say once again, carefully listen about that. When object is kept in the glass slab at the bottom, then what happened? The depth of the glass slab should be equal to actual depth. Then it's going to be raised up. That is about apparent depth. The gap between these two is called vertical shift. With this data, we can find the refractive index of this glass slab. We can find the refractive index of this glass slab. What is the formula? Thickness of glass slab by thickness of glass slab minus vertical shift. If you observe this thickness of glass slab minus vertical shift, what is that? Apparent depth. So, refractive index can be identified by actual depth by apparent depth. Like that also we can identify. Now, based on this, some applicative questions will come. Have understood? Okay, just pause the video once or twice and observe each and every concept. Then you can analyze. Especially you are going to write the competitive examination, this concept is very important. Okay, ma'am? Right. Once or twice, pause the video and observe and note down the concepts. Then it is very easy to analyze about how to find the refractive index and what is vertical shift. Okay, how we have to identify and what is apparent depth and what is actual depth and etc. Now, applicative questions. How they are going to ask? For example, okay, in the water, let us assume a water. Now it is not a board, it is a water. In the physics class, the blackboard, everything is going to happen. We can assume whatever we want. In this, there is a fish. There is a fish. Golden fish is there. Jaloptarani. Like this, a fish is there. In the water. Now, there is a bird. Okay, there is a bird here. There is a bird which is flying over here. Okay, now it's flying and it is observing the fish. Okay, for this fish, how it is going to appear? For this bird, how it is going to appear? Okay, if you know this concept, we should know the basics of 9th class. Where the image is going to be formed? Where the reflected rays are going to meet or refracted rays are going to meet. Remember, this concept is fixed in your brain. Image will form where the reflected rays are going to meet or refracted rays are going to meet. Reflected rays should be meet, then image. Refracted rays are meeting, then image. So the image is always formed where the reflected or maybe the refracted rays are going to meet. The meeting position of the reflected rays will give the position of image. Right. For that, I am going to give one more example here. Okay. Then you can easily analyze this one. It is the interface. It's about interface. And here maybe is one object. And it is about perpendicular line. Okay. And the person is going to observe from here maybe somewhere else. And the light ray is coming like this. From where it is moving? From denser to rarer. Remember here. Denser to rarer. Then what happened to that? It will move away. Right? Very good. Now see, if you are observing from here, where the image is formed, refracted rays are going to meet. So now it is the refracted ray. Means I am extending this. Now it is going to meet here. When I am going to extend this, it is going to meet here. Okay? So that what happened? Here the image will form. Means it is the image. It is the object. But it is the image. If you are going to observe it from here, the object may be not here. It is here. Have you understood? Because it is the refracted ray is going to meet this refracted. This is also a ray. One medium to another medium. Okay, of course, when I say either side, nothing is going to happen because it's perpendicular. Okay, so if you extended this one, these two rays are meeting here. So that what happened? The image will form there. Don't forget, where the reflected rays are meeting, that is the position of image. Where the refracted rays are meeting, that is the position of image. Here they are meeting here, so it is the position of image. If you are observing from here, means you are in the rarer medium, the object is going to be up here raised. That is the reason when you are going to observe your friend in a swimming pool, how is going to appear? Short, and is going to be appear raised. Okay, similarly here, now this bird is going to observe this one. The bird is observing. It is on perpendicular line. And it is another light ray. What is happening is from denser to rarer. So what happens? It will move away from the normal. It is about the normal. When you extend this, it appears like this. So for this bird, the fish is going to appear here. The fish may be here. To whom? This bird. But what about the fish? The fish is seeing this bird from denser to rarer. Then what happened? It will move far away now. So that what happened? It will appear somewhere else. Means apparently. So high. Okay. So if you are going to observe your friend who is in swimming pool, can be shorter. If you are in the water and you are observing your friend, he is going to appear taller. Because it is from denser to rarer, and that is from rarer to denser. Okay, so like that, questions are there. Okay, and how to find the refractive index with the help of a glass slab. Thickness is given like that. We can find. For example, the thickness of the glass slab is about 2 centimeters, and vertical shift is about 0.5 centimeter. How we can find? Vertical shift is given. Vertical shift is about 0.5 centimeter vertical shift, and thickness of the glass slab is about 2 centimeters. Then what is the refractive index? That is the question given. What is the formula for? Thickness of glass slab by thickness of glass slab minus vertical shift. Simply substitute those values. Refractive index is equal to 2 by 2 minus 0.5. It is nothing but 2 by 1.5. How can we write this one? 2 by 3 by 2. Can be written as 4 by 3. Like that you can find. Okay? Right. Okay children? It's about the third chapter of the 10th class. That is refraction of light at plane surfaces. Okay. So, small chapter but very important chapter. Okay. So, in this entire chapter, especially refractive index, table based questions are top most important. Table based questions of refractive index. What happens if the refractive index is increases like that. So, for example, they given like this. Few objects are having refractive index of like this: X, Y, of course, water, kerosene, and 1.50 maybe benzene, water, kerosene, and benzene. Like this, three substances are given. With respect to this one, with respect to this, where there is maximum chances of present TIR, total internal reflection, means from where it has to move? Denser to rarer. So, benzene to water. Denser to rarer. So, like that also the questions may come based on the table. So, here refractive index. Based on the refractive index, so many questions are there. Okay, so once you practice them based on the table. In page number 47, table is there in the textbook. Take the refractive indices and how they are going to changes. If refractive index is increasing, what is happening to the velocity, what is happening to the wavelength, what is happening to the frequency, all the things have to be compared. Okay, because velocity is equal to nu lambda, no? C is equal to nu lambda. But don't forget one thing, when light passes from one medium to another medium, its frequency does not affect it. Its frequency does not affect it. Frequency remains constant. Only velocity and wavelength are going to be changes. Wavelength and velocity will changes, but frequency will remains constant. Frequency remains constant. Okay. So, with respect to this one, you can analyze what is happened to that wavelength, that velocity, etc. And the condition where the light does not deviate and passes perpendicular nothing but the interface, perpendicular to the interface, and both are having the same refractive index. One time that question is given like this: what's a glass rod is immersed in the glycerol? A glass rod is immersed in glycerol, and he is unable to observe the glass rod. What is going to happen? What might be the reason? What might be the reason? Yes, because both are having the same refractive indices. Both are having the same refractive. Glycerol and glass rod are both having same refractive indices. So that when the glass rod is immersed into the glycerol, the glass rod doesn't appear; it disappears. Okay. Similarly, you may take vegetable oil and flint glass. Vegetable oil, flint glass, approximately 1.47 would be the refractive indices. So when you take totally completely filled with vegetable oil and immerse a glass rod in that one, about flint glass, it is also disappeared. Okay, so like that applicative questions are going to be asked. What might be the reason? Identify like that. And why the stars are going to appear twinkling, like aquarium questions. And sometimes a ball has been taken by wounded with ash or maybe smoke. Okay, for example, when you burn a camphor and take a ball and keep on the surface of the camphor, then what happened? It will get ash. Okay, smoke. That smoke has entirely rounded by this ball. When you immerse that black ash ball into the water, what happened? It will appear shine. It will appear shine because of two reasons: refraction and total internal refraction. So like that, the questions may be asked. Once you think, certainly you will get the answers. Okay, first read the questions properly, especially in this chapter. Very easy chapter, very logical chapter. Okay, I think once you pass the videos and recall your doubts and clarify them. Okay, hope for the best. Good luck.